Hi, welcome back to Unit 8 here in AP Physics 1. This is topic 8.2, so this is going to be about pressure. And so we're going to talk about some principles. We're going to talk about what is the basic formula for pressure, and then we'll talk about it in fluids as well. All right, so pressure is going to be defined as the magnitude of the perpendicular force component exerted per unit area over a given surface area as described by the equation P equals F divided by A. Okay, so F is going to be force, A is going to be the area, which oftentimes, as you can see in the little animation here, we have a cylinder. So oftentimes the area is going to be an area of a circle. And so pressure is measured in pascals or PA. And then where does that come from? Is because the volume and density of a given amount of an incompressible fluid is constant regardless of the pressure exerted on that fluid. This is known as Pascal's principle. All right, and this is the basis for hydraulic systems, pneumatic systems. So hydraulics are like hydraulic brakes have some sort of liquid, usually an oil. It could be water as well. Pneumatic is oftentimes with gases. So what we say is that at any point in time, the pressures are going to equal each other. And so you get F1 over A1 equals F2 over A2. And so what happens is, right, based on, the size of a let's say an automobile jack, is how much force would you have to apply to move that car up, right? And so what that jack does is that it just allows us to do a lot of hard work into a simple machine. Now, when it comes to fluids, the absolute pressure of a fluid is going to be equal to the sum of the reference pressure, which is usually atmospheric pressure, and what is known as the gauge pressure. And so let's define gauge pressure before we talk about these equations. So gauge pressure is going to be of a vertical column of fluid is described by the following equation. So P gauge is rho G H. And so what happens is this is a version of potential energy. Okay, so it's basically how much of the fluid above you that's going to affect you, and then the same fluid, right, will have the same pressure at the same depth. So you can have a pond or a lake, put that lake water into a bathtub, and regardless of how much volume you have, it'll have the same pressure, 10 inches down, a foot down, a meter down. Okay, and then if we go back up to the absolute pressure, so what we're saying is that it's going to be some sort of reference pressure plus the gauge pressure at that height. And if you remember, in chemistry, that STP, standard temperature and pressure, for us, it's going to be 1.0 times 10 to the 5 pascals. Sometimes you may see it as 1.013 times 10 to the 5. You just have to use whatever is on the AP sheet, and 1.0 times 10 to the 5th pascals is what's on the AP equation sheet. So let's look at an example problem. All right, so we have a student with a mass of 75 kilograms sitting on a 4-leg lab stool, has a mass of 3 kilograms. Each leg of the stool is circular and has a diameter of 2.5 centimeters. Find the pressure under each leg. Okay. And so what we do is we find how much force is the student putting on the stool by just finding their weight, because that is the force, that is what's being exerted. And so you find that totally the student is exerting 735 newtons, but that is spread out amongst the 4 legs. So we need to find the force per leg. So we do 735 divided by 4, and we find that the student is exerting 184 newtons on each leg. And now we just kind of like keep building to our equation, which is P equals F over A. So we've got force, we need to find area, and so we know it's pi r squared. So 3.14 times 0.0125 squared. Okay, make sure you're converting centimeters to meters. And we find that each leg has an area of 4.91 times 10 to the negative 4th square meters. So now we have everything we need to figure out what is the pressure exerted. Okay, so we do the force of the leg, 184 newtons, divided by the area. Okay, so 4.91 times 10 to the negative 4th. And we find that the student is exerting 3.74 times 10 to the, or I should say the stool, right, is exerting 3.74 times 10 to the 5th pascals worth of pressure. So just some examples, real world examples. So this is the reason why when people wear high heels, they complain that their back hurts, because, this is kind of the structure of a high heel, right? You have a larger area, but that smaller area, right, is what's going to really affect the pressure that they're experiencing. Where if you wear just flats, you have a much larger area over which that force acts. This is also the secret behind the bed of nails demonstration. Okay, basically the reason why the bed of nails doesn't affect a person is because they're taking the pressure from the nails and on their body and expanding it out over that distance, right, or that area. So in the next video, we're going to keep talking about fluids, but now we're going to introduce and see how it is affected by Newton's laws, and then finally in the last video, how it's affected by those conservation laws.